Hey guys, glad you're here for the help video for quiz 4.05. Alright, this is your last Unit 4 quiz, so that's great. Here is your need to know info. Remember, complementary angles are two angles that add up to 90 degrees. And if you look down here at a right triangle, every right triangle has a 90-degree angle, and all triangles add up to 180. So we know in every right triangle that these have to be complementary. Because if we take 180 and we subtract off our 90-degree angle, we're left with 90 degrees. So the measure of angle A plus the measure of angle B is always going to have to equal 90 degrees in a right triangle. So in a right triangle, those two angles are always going to be complementary. All right. Then we have this new thing here that says if the angles are complementary, then the sine of A equals the cosine of B. And the cosine of A equals the sine of B. Well, let's look again at our right triangle to see why that is. If you think about sine of A, if A is our reference angle, sine is the opposite over the hypotenuse. So sine of A equals A over C. Well, now if we think about the cosine of B, if B is our reference angle, cosine means adjacent over hypotenuse. The adjacent side would be A and the hypotenuse would be C. So both of these you can see equal A over C. Alright, so that's something that you might just want to remember or get in your brain. That when you have complementary angles, the sine of A will equal the cosine of B and the cosine of A will equal the sine of B. You can also reverse that statement. Remember, that's called the converse. The converse of that statement is also true. If we reverse it and say, we could say if sine of A equals cosine of B, or cosine of A equals sine of B, then we know A and B have to be complementary. So it goes in both orders. You can use it either way. And then lastly, the Pythagorean theorem. I know we come back to it all the time, but if you have a right triangle and you are missing a side length, you can always use the Pythagorean theorem to find that missing side length. So let's jump in. What is the value of x? Well, we have that the sine equals the cosine, which means our two angles, 49 and x, must be complementary. So if these two angles have to add up to 90 degrees, then we can easily figure out x by just subtracting 49 from 90. So because the cosine and the sine are equal, we know that the angles have to be complementary. So x would equal 41 degrees. All right, and this one, what is the value of x? Well, again, we have that the sine equals the cosine, so we know these two angles must be complementary. So we can take the first angle and add it to the second angle, and those two angles have to add up to 90. All right, so let's solve the equation. We have to combine like terms. 1x plus 2x is 3x. And then we have to do 37 plus 8, which is 45, equals 90. We're trying to solve for x, so we're going to subtract 45 from each side. That will cancel. And then we need to divide by 3 on each side to cancel that out. So we get x equals 15. And the question says, what is the value of x? So that is our answer. Okay, so this one's a little bit different. They give us the sine and the cosine. They're not equal, so we can't just say the angles are complementary. That's not what it's telling us here. But for this problem, y'all, I'm super visual, so I like to draw a right triangle. This makes it so much easier for me. I'm going to use the reference angle x because they're both using angle x. So I'm just going to pick this. I'm going to let that be angle x. Remember, sine stands for opposite over hypotenuse. So from angle x, the opposite side will be 7, and the hypotenuse would be 25. I'm going to do the same thing for cosine. Cosine means adjacent over hypotenuse, and I'm getting these formulas straight from my formula sheet. From my reference angle x, the adjacent side is 24, the hypotenuse is 25, but I've already labeled that. So for me, I like to label the triangle, and then I can easily see that the tangent is the opposite over the adjacent. So I'm going to do opposite over adjacent, and my tangent would be 7 over 24. Now we do need to make sure that that doesn't reduce, but 7 is prime, so there's nothing that we can divide that by, and it doesn't go into 24, so that's it, 7 over 24. Now you could have figured it out right here. Once you labeled 7 as opposite and 24 as adjacent, you could have just gone ahead and plugged them into the tangent without drawing the picture. I just like pictures. Okay, so angle A is an acute angle in a right triangle. Given that the cosine of A equals 15 over 17, what is the ratio for the sine of A? So again, I'm visual. I'm going to go ahead and draw myself a right triangle. You don't have to. I just like to. So I'm going to label this angle A. If it gives me the cosine of A, remember the cosine is the adjacent over the hypotenuse. So the adjacent side to A would be 15, and the hypotenuse would be 17. And I want to know the sine of A. Well, the sine is the opposite over the hypotenuse. So that's what I'm going to try to fill in here. I'm going to try to do opposite over hypotenuse. I know the hypotenuse is 17. What I don't know yet is the opposite side. Well, that's where Pythagorean theorem comes in. Anytime we know two sides of a right triangle, we can find the missing side using Pythagorean theorem. So I'm going to go ahead and do that. A squared plus 15 squared equals 17 squared. Just going to square those numbers. And then I'm going to finish solving for A. So I'm going to subtract 225 from each side. And then I'm going to square root because squares and square roots cancel. And so I would get the positive or negative 8, but it has to be positive because we're dealing with the side length. And so I know that my sine is going to be the opposite, which is 8, over the hypotenuse, which is 17. And you always want to check to make sure that it doesn't reduce, but I can't reduce 17 by anything, so that should be it. So for the next one, given the sine of x equals 0.3, what is the cosine of x? Okay, so this one's a little bit trickier, but again, I'm going to try to draw my right triangle. I'm going to label this side x. The sine is 0.3. Another way of saying 0.3 is 3/10. So for me, I like my sines and cosines to be fractions instead of decimals. So I'm going to turn this back into a fraction. I know 0.3 is the same as a fraction 3/10, so I'm just going to make that a fraction. That's easier for me because the sine represents the opposite over the hypotenuse. So now I can label my picture. From x, 3 is the opposite, 10 is the hypotenuse. And now I want to find the cosine. And the cosine of x would be the adjacent, let me change colors here, would be adjacent over hypotenuse. So we already know the bottom of the cosine of x is going to be 10, but what we don't know is what the adjacent side is going to be. So again, the Pythagorean theorem comes in. To solve for a missing side of a right triangle, you plug it into Pythagorean theorem. So let's do it. A squared plus 3 squared equals 10 squared. And then we're solving for A, so we're going to subtract 9 from each side. This is not going to turn out pretty, but that's okay because it says as a decimal. So then I would square root that because squares and square roots cancel. And I got the square root of 91 is approximately 9.54. So I'm going to put that on top. That's my adjacent side is approximately 9.54. I'm going to put that over 10. And it wants your final answer as a decimal to the nearest 100th. So I'm just going to divide that in my calculator, which really you could just move the decimal, or you could use a calculator. So I got 0.954. And remember, 100 has 2 zeros, so we want to go 2 decimal places. So that 4 would keep the 5 the same. It wouldn't round it up. So my answer for this, for the cosine of x, would be 0.95. All right, y'all, good luck on your quiz.